3D animation is a very powerful feature of vSim for presentation purposes. It allows the visualization of 3D vehicles, 3D signal heads, roadway links with height and thickness, and additional 3D objects, such as trees and buildings, creating a simulated driving environment. To activate the 3D mode, select 3D mode in the View menu, or use the shortcut key Ctrl-D. The background map can also be displayed as a 3D texture. In the 3D mode, additional toolbar buttons become active. Using them, you can pan, rotate network, and fly through the network to have different viewing positions and angles. When simulation starts, vehicles are animated according to the model and color distributions assigned for each vehicle type. If no 3D models are selected, vehicles will be shown as colored boxes in 3D. During the simulation, you can set the viewing position as sitting in the driver's seat. This can be done in a single-step mode by double-clicking on a vehicle. To leave the vehicle, close the corresponding vehicle information window. There is a choice of signal head displays in the 3D mode. It can be accessed from View, Options, Tab 3D, Traffic Signals. By default, red blocks will be placed at the stop line positions to stop vehicles when signal heads show red, and then removed when signal heads turn to green. Instead of this simple way to represent signal changes, you can configure and show real signal heads in 3D animation. To define 3D signal heads, you need to go back to the 2D mode, using the shortcut key Ctrl-D, and then select the Signal Heads Edit mode. Double-click with the left mouse button on a signal head which you want to show as a real signal head in the 3D animation. In the signal head window, press the New 3D Signal button to create the signal and open the 3D traffic signal window. For this first 3D signal head, we select to add new signal to a new arm on a new mast. In the next window, the ID number shown in the window title lists the mast, arm, and signal head numbers in a sequence. You can choose the signal head type between traffic and pedestrian signal, set its orientation, and specify its appearance from the layout drop-down list. The associated controller data shows the signal controller and signal group numbers that should be displayed on this signal head. The selection for left or right will only be enabled if you have selected a layout that contains a bulb with the left or right arrow. Click OK to confirm the setting. In the 2D mode, the 3D signal is shown as a green square with a diamond and a red circle inside. The red circle represents the mast, the red line between two circles represents the arm, and the straight blue arrow indicates the signal head and the direction it faces. You can switch back to the 3D mode to check how this signal head is placed and displayed in 3D. Switching back to the 2D mode, you can further adjust the signal head position. Left mouse click on the green square to select the signal head. It is then highlighted in blue. You can drag the entire signal head to the desired location while holding down the left mouse button. An arm can be resized or rotated around the mast by left-clicking inside the red circle at the far end of the arm and dragging it to the desired length and location while holding down the mouse button. Double-click on the green square to open the Mast Properties window. The ID number in the window title shows the mast identification number. In the lower part of the window, you can set the mast properties, including its appearance, height, and diameter. The Z position defines the elevation of the mast. For example, a positive number can be set for a signal on a bridge. If you left-click to select the arm in the preview field and press the Edit Arm button, it opens the Arm Properties window. The ID number in the window title shows the mast and arm numbers in a sequence. In this window, you can set the style and length of the arm. If you click the signal head in the preview field and press the Edit Signal button, it opens the Signal Properties window. You can further change the signal properties if needed. Back to the Arm Properties window. You can click and drag the signal head to the desired position on the arm while holding down the left mouse button. You can also click and rotate the signal head on a vertical axis by holding down the Control key, or click and rotate the signal head on a horizontal axis by holding down the Control plus Alt key. If needed, you can add additional signal heads or signs to the arm in this window. Back to the Mast Properties window. You can move or rotate the arm along the mast in the same way as you manipulate the signal head. You can also add an additional arm, signal head, sign, and light to the mast. The signal head and sign will be attached directly to the mast, not to the arm. Each arm, signal head, or sign can be selected to hide or delete. Now switch to the 3D mode to see how this signal head is displayed in 3D. Repeat this procedure to create another 3D signal head for the westbound pedestrian movement. It will be added directly on a new mast and set the type as pedestrian. Now, let's run the simulation with 3D signal heads set at the intersection. Besides 3D signals, you can also add and place static objects, such as trees, buildings, or any other user-defined 3D objects at any position within the vSim network. To do this, switch to the 3D mode and right mouse-click inside the vSim window at a position where you want to place a 3D object. In the resulting 3D model window, set the path to the folder where vSim 3D static models are available. In other words, exe, 3D models, static. Click OK to confirm. Built-in 3D objects are then listed in the field to the right. Select tree2.v3d, for example, and click Add to include it in the selected model elements. Click OK to confirm. You will see that a tree is now placed in the network in 3D. You can move a static object horizontally by dragging it with the left mouse button while holding down the Shift key, and move it vertically by dragging it with the left mouse button while holding down the Shift plus Alt key. You can rotate a 3D object by dragging it with the left mouse button while holding down the Control key, and resize it by dragging it with the left mouse button while holding down the Control plus Shift key. You can delete a static object with a left mouse click on the object. vSim can show the elevation of a roadway network in 3D, as well as the thickness of the elevated links for examples such as bridges. To do this, we need to go back to the 2D mode and set the link height and thickness in the Link and Connector Edit mode. For example, to display this link in the lower center of the network with an elevated roadway segment, we will split this link to 3 links and set each link with different height from one end to the other. To split a link, select the link and choose Edit Split Link from the menu, or use the shortcut key F8, and then select a point on the link with the left mouse button to split it. Now double-click on the link to the left to open the Link Data dialog. Under the tab display, you can see the height, the z-coordinate, of the start and end points of the link to be displayed in the 3D mode. For example, begin at 0 and end at 10 feet. When modeling tunnels and underpasses, negative values of height can be used. The height is only used for visualization in 3D. It has no effect on driving behaviors and is independent of the gradient. The gradient specified under the tab Other will change acceleration and deceleration capabilities of vehicles, but it has no visual effect unless the height is defined. Here you can also set the thickness of the line representing the link in the 3D model, for example 10 feet. Check Recalculate Spline Point Height if intermediate points are used to define the link curvature. VSIM will then recalculate the height of intermediate points to reflect a straight height line between the two endpoints. You can switch to the 3D mode to see the difference with or without this option enabled. Next, we select the link in the middle and set its height as begin at 10 feet and end at 10 feet, as well as its thickness as 10 feet. Then we will set the height for the link to the right as begin at 10 feet and end at 0 feet, and the thickness of 10 feet. Now, switch to the 3D mode to see how links are displayed with different heights and thickness. In the previous section, we have learned how to record simulation sessions as animation files. The recorded ANI files can be displayed in both 2D and 3D modes. In addition to ANI files, VSIM allows recording a video of a 3D simulation run using the AVI format. Every feature added to the 3D scene in VSIM can be recorded in the AVI files. In order to show different viewing locations within an AVI file, a predefined set of camera locations can be used. These locations are called keyframes, and they need to be defined prior to the recording. To define keyframes, choose a desired viewing position in the 3D mode. For example, we can start with an overview of the network. Then, select Presentation, 3D Video, Keyframes on the menu bar. In the resulting keyframe window, press New to create a new keyframe entry with the current 3D view. Each keyframe can have a name for easy reference. For example, let's choose a network overview for this keyframe. Starting time is relative to the simulation time where the recording is started. The first keyframe should start at 0 second. Dwell time is the time that the simulation will be viewed from the position defined by this keyframe, say 5 seconds. Movement defines the type of movement between the camera positions of this and the next keyframe. A sinusoidal movement uses slower speeds closer to the keyframe positions and accelerates between them, thus making the movement smoother. A linear movement results in a change of position at constant speed. A linear sinus movement starts with a constant speed and slows down towards the next keyframe. A sinus linear movement starts with an increasing speed and continues with a constant speed towards the next keyframe. When inserting a new keyframe between two existing ones, the option Delay Later Keyframe allows automatically shifting all subsequent keyframes by the dwell time defined in the inserted keyframe. Click OK to finish. You can change the 3D view to define another keyframe without closing the keyframe dialog box. For example, we will zoom to the intersection in the middle and define the second keyframe. The starting time of this keyframe needs to be greater than the dwell time of the first keyframe. Let's set its start at 10 seconds, which gives 5 seconds for VSIM to move from the camera position of the first keyframe to the current position, showing a smooth zooming movement in the AVI recording. Set a dwell time of 5 seconds for this keyframe. Click OK to finish. Now in the keyframe list it also shows the movement time for the first keyframe, that is the time to move from the first keyframe to the second keyframe. Then we can rotate the network to have a side view of this intersection and define the third keyframe. Set the starting time at 15 seconds, dwell time of 5 seconds, and movement type as linear sinus. Then, move downstream from this intersection and define the fourth keyframe with the starting time at 30 seconds. Together, these two keyframes specify a path along the roadway where vehicle movements will be followed and recorded in the AVI file. If you click any keyframe defined in the list, it shows the camera position associated with this keyframe. You may change the 3D view and set the camera position associated with the selected keyframe to the new 3D view by clicking the Update Position button to the right. A keyframe can also be deleted from the list. Keyframes will be saved when you save the network. You can preview the camera movement through all the keyframes defined in the list by selecting all the keyframes and clicking the Start button on the left bottom corner. This simulates the camera movement during recording of an AVI file in the selected speed. During the recording, the keyframes will be run through in the order of start time. If no keyframes have been defined, vSim will record the current view of the 3D model. Any change of the view during the simulation will be recorded. vSim records AVI files that will be played at a constant rate of 20 frames per second. As each simulation time step results in 1 frame, the actual playback speed of the AVI file depends on the simulation resolution, number of time steps per simulation second, specified during the recording. When 10 steps are chosen, the playback speed is twice as fast as real time. When using only 1 time step, then the actual playback speed will be 20 times faster than real time. To start the AVI recording, first check Presentation, AVI Recording from the menu. Then, start the simulation. Select where to save the AVI file and give it a name. Click Open to continue. Then, in the resulting video compression dialog box, select the video compression mode. It is highly recommended to use video compression, as AVI files become very large without compression. The compression modes available depend on the Windows installation. Some compression modes offer additional configuration which can be done within the same dialog box. Click OK to confirm the selection. The AVI recording starts with the simulation.